Can you tell us who you are and what project you are working on?
My name is Mason Anderson, and I was a colleague of Sir Arthur Eddington, and we are working on a project to observe a solar eclipse on May 29th, 1919, and to try to determine the position of stars in the Hyades star cluster.
What were you guys trying to do or find?
Well, in 1915, Einstein published his theory of general relativity. His theory claims that the gravitational field caused by mass has the capability to bend light. In other words, if light passes by an object, the gravitational force from that object would cause the light to appear to be in a different location. The difficult part was testing this theory, because you would need an object with an astronomical mass, such as a star, to make any distortion to the light. The sun is a capable contendant for the object in this experiment, but the light produced from the sun during the daytime does not allow you to see the light from the stars you are trying to measure. The solution to this problem was a solar eclipse. So, 4 years after Einstein's publication of his theory, we were there to prove it and get a more accurate description of the fundamental laws of the universe.
Where did the project or experiment occur?
Well, Arthur and I went along with one group to an island off the west coast of Africa called Principe, while the other group went to Sobral, Brazil, in case of complications with the weather. And sending the second group proved to be a wise decision because of rain and heavy cloud coverage in Principe right up until the day of the eclipse.
What other significant events were happening around the world at that time?
Well, the Treaty of Versailles was being signed because of the events that happened in the preceding years. You might have remembered it. It was World War I. The war made it difficult for us to make our deadline. With all the factories producing war supplies, we could not get our supplies we needed, and the project was delayed. It was not until the war was over that we could start, which left us with only 5 months to accumulate all our supplies that we needed.
Who else was involved in the project?
Sir Frank Watson Dyson, Astronomer Royal of Britain, was one who conceived the experiment in 1917. Along with Eddington leading, the Royal Society and the Royal Astronomical Society were involved in sending people on the expedition. Lastly, we cannot overlook Einstein's contribution to this experiment. He's the one who got all this started in the first place.
What was your role in the project?
My role was to assist in the calculations to determine the distortion caused by the sun. We had previously found the known location of the stars without the influence of the sun. What we had to do was determine the location during the eclipse to find the amount of change in the position of the stars. This may sound like an easy task, however, it proves to be very difficult. After the experiment, though, our calculations showed that the image of the star was bent by 1.75 arc seconds. And to give you a comparison, that's like something almost 2 miles away from you moving an inch.
What impact did your project have on the physics community?
The proving of Einstein's theory drastically changed the way physicists viewed the ideas of space-time and allowed for incredible advancements in physics all the way up to this day, such as trying to understand dark matter and the expansion of the universe.
Okay, last question. Were there still skeptics claiming that your results were inaccurate and biased, and has this experiment been replayed to provide more reliable and accurate results?
Yes, many astronomers accused Eddington of manipulating his data because some of the data from the group in Brazil was not used. The telescopes gave data that closer supported the previous theories before Einstein's, but their telescopes had been warped from the heat, which could have provided inaccurate data. In addition, the experiment has been repeated several times, once in 1922 by astronomers at Lick Observatory in California, another time in 1953, and in 1973, and etc. Each time the experiment was done, the data better supported the theory than before. And by the 1960s, Einstein's theory was well accepted in the physics community.